All right, we got any questions? All right.
I wish I had an hour. Is anybody here familiar with ModTran or similar programs? And, well, three of us, I assume, use it. And what it does, it looks at radiation leaving the Earth over the average, the annual average. And it's a pretty crude way, but it comes out pretty handy. And you have a certain watts per square meter at, say, 280 ppm, and you get a lower watts per square meter at 560 ppm. That's one way of looking at the climate sensitivity, okay, or 400, 800, whatever. You get that delta watts per square meter. And then the trick is to convert that to change in the surface temperature of the Earth. Which can be done. My associate here has done it his way. I've done it my way. We come out with the same answer.
Yeah, that's a good observation. There's been some data that I didn't include in my slide, just to keep it brief, but the ERBE satellite, ERBE, is a NASA satellite that has been measuring radiation that leaves the Earth's atmosphere into space. And according to the alarmist, quote, consensus computer models, they have a certain prediction because they expect that water vapor is increasing and you're getting more cirrus clouds and they're trapping so much more CO2, or excuse me, trapping so much more heat, more long-wave radiation. And another way that we've been able to show that the models are just not reflecting reality is those satellites show that there is more radiation escaping the Earth's atmosphere into space than would and should and would be the case if the Earth's climate were behaving as the models predicted, and that's another objective piece of data. One other thing I just want to say, as a host of the conference, having an international conference here, of course, presents many challenges as far as making sure that it's not American-centric. And if I were in Estonia, I couldn't even order a cheeseburger. So I think it's fantastic that Dr. Karner is able to take all of this scientific information and convey it as well as he can, and his work is just fantastic. So thank you for the extra effort to do this in a foreign language. I appreciate it.
Thank you.
Yeah.
We'll look into it. I'll look into it. Send me information. I appreciate that. And we'll try and keep the questions to 60 seconds so we can get a few, but thank you.
How does a doubling of the CO2 concentration change the temperature of the ocean warm pools when your wind-driven evaporation is 200 watts per square meter and your uncertainty in the wind-driven evaporation is an order of magnitude at least larger than the global warming that they're predicting from CO2 in terms of the infrared flux coming into the ocean?
Is that for anyone in particular? I'd be happy to take it, but if anyone else? What's real interesting with the climate models is as they see that temperatures haven't warmed as they had predicted, now they look for other ways to explain it. And for the longest time they talked about, it was even identified as factor X. And now because we have not been able to measure deep ocean temperatures. We don't have a long time frame. The assertion is, well, it must be in the deep oceans. And of course, you have the factors that you talk about. But in terms of looking at the impact on climate sensitivity, which the panel here is addressing, those assertions that the warming is being hidden in the oceans, one, are very speculative, two, don't have any data backing them up, and three, I would argue that even if that's the case, that would be a good thing because it means that instead of the warming accumulating in the surface and affecting the Earth's ecosystems and human health and civilization, et cetera, the oceans can store it much more effectively, and we're not going to see the impacts. I agree. I was just amplifying your point.
This question is for Bob Armstrong. He gave us a teaser up there where he was about to demolish Jim Hansen's understanding of the climatology of Venus. And I would like to hear what the point was that you were trying to make. And I hope that from that there's a further implication that this also, shall we say, raises a question about James Hansen's understanding about the climatology of the Earth.
Well, yeah, one of the things is I implemented these basic, physics that I really think can be gotten across at a high school level in terms of the computations, and now that anybody can go and download free versions of these languages, they can do, and I can see it being great science projects. What I don't understand is how Jim Hansen. The bottom line is, and I could go back to the slide, the bottom line is that you can calculate what the temperature is going to be for a ball by looking at the ratio of the absorptivity versus the emissivity times the temperature of a gray ball, a flat spectrum ball. Venus, the surface temperature is 2.25 times. It would be great to have the slides back. But
go ahead.
Pardon?
Say, go ahead. Knock yourself out.
Can you get the slide back? That's second to last slide.
Yeah, it might be difficult. It might be a little difficult.
Yeah,
Okay.
and one of the things. Okay. Oh, there we go. Whoa. Okay. Yeah, we're getting through there. Right. Let's go back just a couple here. One of the things. Here essentially is working out. No, that's not working. The equation there goes and shows the absorptivity. Oh, it's off the slide anyway. Times the gray body temperature. Yeah, the gray body temperature times the absorptivity divided by the absorptivity raised to the 1/4 power. Here it is. I did an approximation for deep water, and to go and give a realistic sort of skipping one, doing odd things. Anyway, well, this is showing these three things, but the thing is that ratio is here. Let me go forward to the. Yeah, it's about 2.25. Actually, on Science of Doom, somebody posted in a conversation, this is the most absorptive material that humanity has yet been able to make. It's a very sophisticated surface with a quartz outer cover that is interference size, and titanium oxide, and copper. That has a ratio of 2.21 in terms of the temperature that a ball would have surfaced with that material. I find that amazing. But it manages to do that partly because its absorptivity is 0.95, and its emissivity is about the same as what aluminum is in the IR. The thing is that Venus is I actually recently saw a number of 0.3, but 0.1 I've heard absorptivity for Venus. Venus is an order of magnitude. I mean, Venus has got a ratio of 2.25 times. The surface temperature is 2.25 times what the temperature of a gray ball in its orbit is. We're talking here, our temperature is about 3% higher than a gray ball in our orbit. And the entire variation we're talking about on this is on the order of 0.3%. But Venus's surface temperature is greater, the ratio is greater than humanity has been able to create. And it does that by starting off with something that's 0.95 absorptive. So it just simply cannot be explained. And so CO2 is good stuff. Pardon?
The explanation is the lapse rate on Venus. It's a heat engine.
Show me the equation. You can't get it. I mean, the lapse rate in that material is extreme. I mean, one of the things is pressure, is in the, dynamic change in pressure will change temperature, but pressure per se, boy, if you could just go and make something
Venus
hot,
is huge.
Pardon?
The pressure, the atmosphere on Venus is huge. I don't remember the details.
But the thing is that actually, first of all, Venus, everything is absorbed rather far out. But furthermore, you simply can't get it. One way or another, you have to produce something. The radiative balance is just simply not affected by...
You're not in equilibrium.
Pardon?
You're not in equilibrium. What is the peak temperature of the flux from the sun? It's not the average, it's the peak.
But the sun is thermonuclear reactions going on. The bottom line with Venus is that it has to have internal heat. It cannot be explained. It cannot. You go and produce some material, some ball that manages to go and have that sort of a ratio, and then I'll believe you. But the equations don't compute. It doesn't compute.
All right, I'm going to call timeout on this right now. Is there anyone else that has a question? All right.
Yeah, this is for James Taylor. As far as those computer models, the models don't seem to match up with the observations, including past climates and also quantities over the 20th century, like the relative humidity. Well, why do these models persist? I mean, there's about 100 of them, that maybe the IPCC has quoted, and they've had, I don't know, over the last 20 years, they've been trying to match up, data, observations with the models, but they still seem to be wrong. What's going on? Why do they persist?
Yeah, that's a good question, and I think probably over the plenary sessions over the past couple days, many of the reasons have been discussed. There's money in the grants. There's people that are going to continue to be prominent in their field and in the discussion. But what's real important, I think, was an admission by Hans von Storch, who's the lead author for the IPCC, who last year in an interview with Der Spiegel said, we have this pause, the models can't account for it, we're getting to a point where we're at a 5% run might be able to account for it, which is really pushing coincidence, and if this doesn't change soon where we see a significant warming, we are going to have to go back and revise those models, and that was over a year ago, and I think even then it was pretty clear. And when you make a prediction, the prediction doesn't come true, and I understand there's variabilities in terms of time scale, and longer time periods are more useful, but at some point you have to acknowledge that there's something wrong with the models, and don't take it as a personal attack or that you're not a qualified scientist or whatever, because even the greatest scientists have made predictions and theories that didn't come true.
All right, is there anyone else with a question? All right, lunchtime.